Now, second question is attempt any three of the following. Second question is attempt any three of the following. First question, if A is equal to 3 2 minus 1 4, B is equal to 1 minus 3 2 0. Find x such that 2x plus 3a minus 4b is equal to I. So, take a solution. First of all, we have this equation 2x plus 3a minus 4b is equal to I. So, we have to find 2x. We keep this 2x as it is and I as it is, and shifting this 3a, so here we get minus 3a plus 4b. So we put I matrix, that is identity matrix 1 0 0 1, minus 3 as it is. We put A here 3 2 minus 1 4 and plus 4 as it is. B matrix is 1 minus 3 2 2 0. So after putting values 1 0 0 1 as it is, minus 3, here we multiply, scalar multiplication, 3 3s are 9, 3 1s are minus 3, 3 2s are 6, 3 4s are 12. Then multiply by 4, 4 1s are 4, 4 3s are 12, minus 12, 4 2s are 8, 4 0 0. Now solve this at a time. 1 minus 9 plus minus by first, then plus 4. Next 0 minus minus plus 3, then minus minus 3 and plus 8. Now 0 minus 6 and plus minus 12. Then minus 8. Then 1 minus 12 and plus 0 here. So we get 1 minus 9 minus 8 plus 4, minus 8 plus 4. Then 0 minus minus plus 3 plus 8. Here minus 6 plus minus minus 12 and 1 minus 12, that is minus 11 plus 0. Now we get final answer minus 4 plus minus 8 plus 4, we get minus 4. 3 plus 8, 11. Minus 6 minus 12, that is plus 12 plus 6 minus 18 and minus 11. So we get 2x is equal to minus 4 minus 18, 11 minus 11. Now we have to find x. So we shift these two here, 1 upon 2 into minus 4 minus 18, 11 minus 11. So we get minus 4 by 2 minus 18 by 2, 11 by 2 and minus 11 by 2. So finally we get 2 2s are 4, that is minus 2 here, 2 9s are 18, minus 9, 11 by 2 and minus 11 by 2 is the final answer. So x is equal to minus 2 minus 9, 11 by 2 minus 11 by 2 is our final answer. Second question, B's question is resolve into partial fraction x square plus 1 upon x into bracket x square minus 1 by using partial fraction. Here we have first type of partial fraction, that is x square plus 1 upon x into x square minus 1. So we put a upon x plus b upon x plus 1 plus c upon x minus 1. here x square minus 1's factor is x plus 1, x minus 1. So x square minus 1's factor is x plus 1, x minus 1. That is a square minus b square, a plus b, a minus b. A square minus b square is equal to a plus b, a minus b. X square minus 1 is equal to x plus 1, x minus 1. So by using first type, x square plus 1 upon x into x square x minus 1 is equal to a into x plus 1, x minus 1. See this, we put here a and multiply remaining denominators x plus 1, x minus 1. Then b into, we put b and remaining denominator x into x minus 1, and plus c here x into x plus 1. X into x plus 1, and denominator is x into x plus 1 into x minus 1. So these denominators get cancelled. We get x square plus 1 is equal to a into x plus 1, x minus 1, plus b into x minus 1, and plus c into x plus 1. So we put equation 1 here. After getting equation 1, we have to put values of x, so we can find a, b, c. So first of all put x is equal to, see what we have to put here, x is equal to 0, and here also x is equal to 0. So we get b and c is omitted. So put x is equal to 0 in equation 1. So x is equal to 0 plus 1 is equal to a into 0 plus 1, 0 minus 1, plus b into 0, 0 minus 1, plus c into 0, 0 plus 1. Now see, 0 plus 1, 1, a into 1, and 0 minus 1, here we get minus 1, c is 0, then whole term is 0, c here also 0, c is also 0. So we can omit this by putting 0 and here also 0. So we get 1 is equal to a into 1 minus 1. There is no need to write 0 here. So we can get 1 upon minus 1 is equal to a. So a is equal to minus 1. We get a is equal to minus 1 here. Now we have to find b. We can put x is equal to c. X plus 1, here also x plus 1. So a and c can omitted by putting minus 1 here in equation 1. So x is equal to minus 1. So here minus 1 square plus 1 is equal to a into minus 1 plus 1, minus 1, minus 1 minus 1, plus c into minus 1 plus 1. So we get minus 1 square is plus 1, 1 plus 1, and here a, see this, minus 1 plus 1, 0. So there is no need to write a. B minus 1 here, and minus 1 is minus 2. See this also, here also minus 1 plus 1, so there is no need to write c also. So we get 2 is equal to b into minus 2 into minus 1, that is 2 1s are 2 plus 2, and here 2 upon 2 we get b, 2 by 2 is equal to 1. So b is equal to, we get 1, b is equal to 1. So we get b here. We have to calculate c. So put x is equal to, see this, here x minus 1 and here also x minus 1. By putting 1 we can omit this a and b. So x is equal to 1 in equation 1. So we get here 1 square is 1 plus 1 is equal to a into 1 plus 1, 1 minus 1 plus b into 1, 1 minus 1 and plus c is equal to into 1, 1 plus 1. So we get 1 plus 1 is equal to 2, a is equal to 1. So there is no need to write a. See this 1 minus 1 0, then whole term is 0. Also see this b 1 minus 1, so here also we get 0. So there is no need to write a and b because that is 0. So c is equal to 1 and 1 plus 1 2. So we get 2 is equal to c, 2 ones are 2. So we get 2 by 2 is equal to c. Here also we get 1. We get 1. Here also we get c is equal to 1. So finally c is 1. We get values of a is equal to minus 1, b is equal to 1 and c is equal to 1. So put these values in this equation. We get x square plus 1 x into x square minus 1 is equal to a. We have a minus 1 upon x plus b 1 upon x plus 1 and plus c is 1 upon x minus 1. So finally we get this answer, minus 1 upon x plus 1 upon x plus 1 plus 1 upon x minus 1. Question number 2. Third question C. The voltage in an electric circuit related by following equation: V1 plus V2 plus V3 is equal to 9. Second equation is V1 minus V2 plus V3 is equal to 3. And third equation is V1 plus V2 minus V3 is equal to 1. Find V1, V2 and V3 by using Cramer's rule. So by using Cramer's rule we have to solve this. We have given three equations. First one is V1 plus V2 plus V3 is equal to 9. That is equation 1. Second one is V1 minus V2 plus V3 is equal to 3. That is equation 2. And third one is V1 plus V2 minus V3 is equal to 1. That is equation 3. So by using Cramer's rule we have to find first of all D. So to finding D we have to take 3 by 3 determinant. So first one is V1, V2. V1's value here, V1's value is coefficient of V1 is 1, then here also 1, here also 1. Then coefficient of V2 is plus 1, see here, then minus 1 and here 1. Then V3's coefficient is 1, see here 1 and here minus 1. By solving this 3 by 3 determinant we can find D. So take plus minus plus. Put 1 here, then 2 by 2 determinant, then minus 1, then also 2 by 2 determinant and plus 1, 2 by 2 determinant. So take this column and this row will be omitted. We have minus 1, 1, 1 minus 1. See this minus 1, this column and this row get omitted. 1, 1, 1 minus 1. And last one plus 1 is this column and this row omitted. We have 1, 1 minus 1, 1. So 1 as it is, we take cross multiplication, minus 1 into minus 1 minus 1 into 1. Minus 1 as it is, 1 into minus 1 minus 1 into 1. Then last one 1 as it is, 1 into 1 minus 1 into minus 1. So here 1 as it is, 1 into minus 1 into 1, that is 1. Minus as it is 1 into 1, 1. Minus 1 as it is, see multiplication 1 into minus 1, that is minus 1. Minus 1 into 1, 1. Plus 1 as it is, 1 into 1, 1. Minus 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 plus 1 into 1, 1. So 1 as it is, 1 minus 1 0, minus 1 as it is, minus 1 that is minus 2, plus 1 as it is, 1 plus 1 2. So we get minus 1 into minus 2 and plus 2. So minus 1 into minus 2, that is plus 2, that is 4. So final answer D is 4. After finding D, we have to find dV1. So by Cramer's rule, 3 by 3 determinants, we have to take dV1. We have to take, instead of V1's value, we have to take this right hand side values 9, 3, 1 here. Then as it is V2's value, coefficient of V2 is 1, minus 1, 1, and here 1, 1, minus 1, that is V3's coefficient. Instead of V1, we have to take 9, 3, 1, right hand side's value for finding dV1. So again by solving 3 by 3 determinant, we get dV1. So plus 9 as it is, 2 by 2 determinant, minus 1 as it is, 2 by 2 determinant, and plus 1 as it is, 2 by 2 determinant. Plus 9, see this column and this row get cancelled. Minus 1, 1, 1, minus 1. Now minus 1, this column and this row get omitted. 3, 1, 1, minus 1. And last one, plus 1, this column and this row get omitted. 3, 1, minus 1, 1. By solving this, 9 as it is, take cross multiplication, minus 1 into minus 1, minus 1 into 1, minus 1 as it is, 3 into minus 1, minus 1 into 1, and last one, plus 1 as it is, 3 into 1, 3 into 1, minus 1 into minus 1. So we get 9 as it is, minus 1 into 1, minus 1, that is plus 1, minus 1 into 1, 1, minus 1 as it is, 3 into minus 1, minus 3, and 1 into 1, 1, plus 1 as it is, 3 into 1, 3, and minus minus plus 1 into 1, 1. So 9 as it is, 1 minus 1, 0, minus 1 as it is, minus 3 minus 1, minus 4, plus 1 as it is, 3 plus 1, 4. So here 9 into 0, 0, minus 1 into minus 4, that is 4, and 4 plus 1, that is 4 into 1, 4, 4 plus 4, 8. So dV1 is 8. Now after solving dV1, we have to find dV2. So by taking determinant 3 by 3, dV2, first put V1's coefficient 1, 1, 1. Instead of V2's coefficient, we put right hand side value, that is 9, 3, 1. And as it is coefficient V3, 1, 1, minus 1. Again solving 3 by 3 is determinant, plus minus plus. So see this, plus 1 as it is, this 2 by 2 determinant, minus 9 as it is, 2 by 2 determinant, and plus 1, 2 by 2 determinant. So take this, plus 1, this column and this row get omitted. We have 3, 1, 1, minus 1. Then minus 9, this column, this row get omitted. We have 1, 1, 1, minus 1. And last one, plus 1, this column and this row get omitted. We have 1, 1, 3, 1. Now 1 as it is, again multiplying, cross multiplication, 3 into minus 1, minus 1 into 1, minus 9, then 1 into minus 1, minus 1 into 1, plus 1, 1 into 1, minus 1 into 3. So we get 3 into minus 1, minus 3, minus 1 into 1, 1, minus 9 as it is, minus 1 into 1, that is minus 1, minus 1 into 1, minus 1 into 1, 1, plus 1 as it is, 1 into 1, 1, minus 3 ones are 3. So 1 as it is, minus 3 minus 1, minus 4, minus 9 as it is, minus 1, minus 2, plus 1 as it is 1 minus 3, that is minus 2. So we get minus 4 here, 9 to the 18 plus 18 here, plus minus 2 1s are 2. So minus 4 minus 2 plus 18. Minus 4 minus 2 is minus 6 plus 18. And 18 minus 6 we get 12. So dV2 is 12. We have to find dV3. So we take again 3 by 3 determinant. See this, V1's coefficient as it is 1 1 1, V2's coefficient also as it is plus 1, then minus 1 and plus 1. Instead of V3's coefficient we take right hand side values 9 3 1. So put here plus minus plus, take this plus 1, 2 by 2 is determinant, minus 1, then 2 by 2 determinant, and plus 9, then again 2 by 2 is determinant. So take this column and this row get omitted. We have minus 1 1 3 1. Then minus 1, this column and this row get omitted. We have 1 1 3 1. And 9 plus 9, this column and this row get omitted. We have 1 1 minus 1 1. So 1 as it is, they take cross multiplication, minus 1 into 1 minus 3 into 1, minus 1 into 1 minus 3 into 1, and plus 9 as it is, then 1 into 1 minus 1 into minus 1. So 1 as it is, minus 1 into 1 minus 1, minus 3 1s are 3, minus 1 as it is, 1 into 1 1, minus 3 1s are 3, plus 9 as it is, 1 into 1 1, minus plus 1 into 1 1. So we get minus 3 into 1 minus 1 minus 4, minus 1 as it is, here we get minus 2, plus 9 as it is, we get 1 plus 1 2. So 4 1s are 4, minus 4, minus plus 2 1s are 2, plus 9 2s are 18. So we get minus 4 plus 2, that is minus 2 plus 18, and 18 minus 2 we get 16. So dV3 is 16. Final answer is 16. By using Cramer's rule, we have to find V1. So V1 is equal to dV1 upon D. That is, dV1's value is 8 and D is our 4. So we get 2 here. V1 is 2. Now V2, dV2 upon D. So dV2's value is 12 and D is 4. That is 3. V2 is 3 and V3 is equal to dV3 upon D. That is dV3 is 16 upon 4. That is 4. So we get V1 is equal to 2, V2 is equal to 3 and V3 is equal to 4. So we get V1 is equal to 2, V2 is equal to 3 and V3 is equal to 4. Finally, question number 2 is fourth question. D question is calculate the mean deviation about the mean of the following data. So data is 3, 5, 6, 7, 10, 12, 15 and 18. We have to find mean deviation about mean. So we have to find first of all mean and mean deviation here. So we require one table. In that table we have given xi. This values 3, 5, 6, 7 is xi's value. So we put 3, 5, 6, 7, 10, 12, 15 and 18 here. So we have to require summation of xi is 78. So 70, not 78, 76. We have to sum, means add this one, the 3 plus 5, 5 plus 6, then whole this addition, we get summation of xi, that is 76. Now we have to find di. So di is xi minus x bar. First of all, we find x bar. X bar's formula is summation of xi upon n. Summation of xi is 76 and n means total numbers 1, 2, 3, 4, 5, 6, 7, 8. We have 76 upon 8. So we get x bar, that is mean is 9.5. We have to find di. So we can write formula first of all di. Here di is equal to xi minus x bar. We can write xi minus x bar is equal to di. Xi minus x bar is equal to di also. So we have to find di. We take xi is equal to 3 minus x bar is, our x bar is 9.5. So we get minus 6.5. First value is minus 6.5. Now second 5 minus 9.5. So we get minus 4.5. Now 6 minus 9.5. So we get minus 3.5. Now 7, xi is 7 minus 9.5. So we get minus 2.5. Now 10 minus 9.5. We get plus value, that is 0.5. Now 12 minus 9.5. 12 is our xi and 9.5 is x bar. So 12 minus 9.5 we get 2.5. Now 15 minus 9.5 we get 15 minus 9.5, that is 5 minus 5.5. And last one 18 minus 9.5 we get 8.5. So here we find di. Now we have to take mod di. So in mod we have to take only plus value. Instead of minus we take plus value. So here first value is 6.5 plus 6.5, then 4.5, then 3.5, then 2.5. That is only plus value. Instead of minus we take plus. 0.5, then 2.5, then 5.5, and last one is 8.5. After taking mod di, we have to find summation of mod di. Means add these all terms, 6.5 plus 4.5 plus 3.5 plus 2.5 plus 0.5 plus 2.5 plus 5.5 plus 8.5. So summation of di is 34. So we get here summation 34. We can add by using calculator also. Summation we can add by using calculator. So we get here 34. So we have to find mean deviation. Mean deviation's formula is summation of di upon n. We have summation of di. So value of summation of di is 34 and our n is, already I told you, n is number of elements or number of values, 1, 2, 3, 4, 5, 6, 7, 8. So our n is 8. So we take here 8. 34 upon 8 by using calculator we can find, that is value of 34 upon 8 is 4.25. So last our mean deviation is 4.25.